Hello children, welcome to the new session of the chapter solutions, and today's topic is mole fraction. By today we'll be completing all our concentration terms. So today we'll be doing mole fraction, PPM and PPB. Okay, in the next session we'll be seeing how do we relate these concentration terms and how to solve numericals when more than one concentration term is used in the question. For today we'll be seeing three concentration terms: mole fraction, PPM and PPB. Now, when we talk about mole fraction, as I have been telling you from the starting of the solutions chapter, in this chapter mainly we will be dealing with binary solutions. What do you mean when I say binary solutions? In binary solutions, we have only two components, okay, A and B. Okay, one will be solute and obviously the other will be solvent. The one which is there in highest number of moles will be solvent and the one with least number of moles will be solute. Okay, now here I have taken a solution which has two components A and B. Okay, now the number of moles of A in the solution is considered to be Na, and the number of moles of B in the solution is considered to be Nb. So the total number of moles in the solution is Na plus Nb. Now when we come to what exactly is the mole fraction, it is the ratio of number of moles. It is the ratio of number of moles of a component. It is the ratio of number of moles of a component to the total number of moles of all the components in the solution. So what is mole fraction? It is a ratio of number of moles of a single component to the total number of all the components in the solution. How do we understand this? For example, I have taken a solution in which I have two components A and B. Now A will have its own mole fraction and B will have its own mole fraction. Means what? When I say A will have its own mole fraction, means what? Okay, now with respect to the total solution, A's fraction is a certain amount. Now when we compare to the total solution, B's fraction of total number of moles is certain amount. Now when I combine this, that will be equal to 1. Now to understand it better, let us understand like this. For example, if I want to calculate mole fraction of component A, okay, mole fraction of component A, then what I will do? Number of moles of that component means number of moles of component A divided by total number of moles, which is Na plus Nb. Okay, how do we calculate the mole fraction of component A? Number of moles of component A divided by total number of all the components present in the solution. Here I have taken a binary solution, so I am writing Na plus Nb. In the same way, if I want to calculate the mole fraction of B, okay, it is the number of moles of B plus total number of moles. Okay, so this is mole fraction of component A and this is mole fraction of component B. How do we get mole fraction of component B? Number of moles of B divided by total number of moles. So by this I got my I can calculate mole fraction of component A and mole fraction of component B. See, if you see your previous concentration terms like molarity, percentage composition, we were calculating concentration of the whole solution. We were not individually calculating it. Now when we come to mole fraction, we are individually calculating it for each component. It is not like you are doing it for the total solution. Okay, how many ever components the solution might have, mole fraction will do it for individual components. Okay, so this is not for the whole solution at once total, but here we are going to calculate mole fraction of every individual component present in the solution. So what can I write? It is individually calculated. It is individually calculated. It is individually calculated for all the components. It is individually calculated for all the components in the solution. How many ever components you might have in the solution, for every component we can calculate the mole fraction. One more thing you can understand here is mole fraction of component A plus mole fraction of component B will always be equal to 1. So if I add all the mole fractions of a solution, the sum of all the mole fractions is definitely equal to 1. For example, if I take a solution in which I have components A plus B plus C, like I am taking a tertiary solution. In this, individually I can calculate mole fraction of A, individually I can calculate mole fraction of B, individually I can calculate mole fraction of C. Now when I add all these mole fractions, the total sum is equal to 1. Like how many other components might be there in the solution, but the sum of the mole fractions of all the components will always be equal to 1. For example, if you take the whole is equal to 1, means what? Mole fraction of A can be 0.2, mole fraction of B can be 0.4, mole fraction of C can be 0.6. Now if you add each fraction of every component in the solution, the total sum will be definitely equal to 1, because the whole unity, the whole setup of the solution, the complete solution, I am taking it as a single unity. So whichever mole fraction is contributing to it, the sum of all the mole fractions should always be equal to 1. Now individually if I want to see here, now can I write from this? Mole fraction of component A is equal to 1 minus mole fraction of component B. So in the exam, if you want to make it simple, you can calculate mole fraction of one component. Later other component, you need not do a very big calculation. You can just do 1 minus the mole fraction of the other component. Okay. So in the similar way, I can also write mole fraction of B is equal to 1 minus mole fraction of A. So if you know the mole fraction of one component, it is very easy to calculate the mole fraction of other component, because ultimately sum of both of them is equal to 1. Now if you are thinking how is sum of both of them is always equal to 1, can you prove it? Now let us see how is it actually equal to 1. Okay, for that if you see, mole fraction of A plus mole fraction of B is equal to, so what is mole fraction of A? Na divided by Na plus Nb. Okay, plus what is mole fraction of B? Nb divided by Na plus Nb. Okay, now when you add both of them, okay, what do you get here? Okay, if you take LCM, this will be equal to Na plus Nb. Okay, so in the numerator you will get Na plus Nb. Now you can cancel out Na plus Nb and Na plus Nb, so you will get it equal to 1. So you can mathematically also prove why is mole fraction or sum of mole fraction of two components or any number of components present in the solution is always equal to 1. You can see it. Okay, if I add the mole fractions of both the components, ultimately what am I getting here? I am getting the answer as 1. Okay, so this is the basic understanding of your concept mole fraction. Okay, now to understand any concentration term in a better way, we need to do numericals on that. Now let's try and solve numericals on the concept mole fraction. Now let us see a numerical on the concept mole fraction. Calculate the mole fraction of H2O in a mixture containing 0.4 grams of NaOH and 1.8 grams of H2O. Okay, let us calculate this. Okay, if you see here, we have a solution. Okay, in the solution, what are the two components? One component is H2O and other component is NaOH. Okay, so I have two components. He is asking me to calculate the mole fraction of H2O in a mixture containing 0.4 grams of NaOH and 1.8 grams of water. So mole fraction of water is equal to number of moles of water divided by total number of moles of all the components present in the solution. So how many components do you have in the solution? Two components, NaOH and H2O, divided by number of moles of NaOH plus number of moles of H2O. Now, do I have the number of moles of NaOH and H2O in the question? No, I don't have. But I have the mass of both the components. Now, you people know how to calculate the moles when we know the mass of the given component. Now, let me calculate first number of moles of NaOH is equal to given mass of NaOH. How much is the given mass of NaOH? 0.4. Already we did this many times. What is the molecular mass or molar mass of NaOH? Molar mass of NaOH is 40. So 0.4 divided by 40, that is equal to 4 by 100. Sorry. Okay, that is equal to 4 by 400, which will be equal to 1 by 100, that is equal to 0.01. In the same way, let me calculate the number of moles of water. number of moles of water is equal to, what is the mass of water given? 1.38. We know molar mass of water is 18. Okay, so this will come to 18 by 180, so which is your 1 by 10, that is equal to 0.1. So number of moles of NaOH is equal to 0.1, number of moles of H2O is equal to, sorry, here it is 0.01, number of moles of H2O is equal to 0.1. Now let us substitute it here. Mole fraction of H2O is equal to, how many number of moles of water I got here? 0.1 divided by number of moles of NaOH 0.01 plus number of moles of water is 0.1. Okay, using this you can calculate the number of mole fraction of your H2O. Now if you calculate this, how much do you get? 0.1 divided by 0.01 plus 0.1 will come to 0.11. Okay, 0.11. Now if you calculate this, how much will you get? Yes, how much will be the value of 0.1 divided by 0.11? You can write what? 1 by 10. Okay, divided by 11 by 100. Okay, this I am writing it as 1 by 10 divided by 11 by 100. Now you can write it as 1 by 10 into 100 by 11. Okay, 10 will go 10 times. So what is the mole fraction of water here? Mole fraction of water is equal to 10 by 11. So this is the mole fraction of water I got by calculating it using the formula. So I didn't have directly the number of moles, so I have calculated number of moles by using mass of the respective components given in the question. Now in the question they have asked mole fraction of H2O. Now our job is done. We have calculated mole fraction of H2O. But because we know the concept, we can even try and find mole fraction of NaOH2. Though it is not given in the question, we know how to do. So we can quickly give a try. So we know that mole fraction of NaOH plus mole fraction of H2O should be equal to 1. Okay. Now from this, I can calculate mole fraction of NaOH. See, again you can write the formula of mole fraction of NaOH is equal to number of moles of NaOH divided by number of moles of NaOH plus number of moles of H2O. But that is a lengthy process. Instead of that, what can I do? Because I know sum of both the mole fractions of these components is equal to 1. I can write from here mole fraction of NaOH is equal to 1 minus mole fraction of H2O. So what will that be equal to? 1 minus 10 by 11. Okay, 1 minus 10 by 11. Okay, I think you can do the calculation here. You can take 11 as the LCM. So 11 minus 10, that is equal to 1 by 11. And mole fraction will not have any unit. Okay, if you want to write down here, mole fraction is unitless. Why is the mole fraction a unitless quantity? Because it is a ratio, right? It is a ratio of same type of components. So there will not be moles will get cancelled. So there will be no unit for the mole fraction. So what is the mole fraction of H2O here? 10 by 11. Then using that I have calculated mole fraction of NaOH, which is equal to 1 by 11. Okay, mole fraction of NaOH, which is equal to 1 by 11. Okay, so this is how you can do the mole fraction questions. Okay, now let us do one more question. Like it is not always that they will give you directly mass. Sometimes they give other concentration terms also, and using other concentration terms you should be calculating your mole fraction. Okay, if I say like this you won't understand. Let us take one more question for mole fraction and understand it in a better way. This question hope you have understood. We'll do one more question on mole fraction. Let's see one more numerical for mole fraction. Calculate the mole fraction of NaOH in 40% mass by mass aqueous solution. Now this is what I was talking about. Okay, when we are trying to solve one questions on particular to one concentration term, it is not always compulsory that the data will be confined only to that. They will be bringing other concentration terms also into that. That is the reason when I was teaching you percentage compositions, I was very clearly telling you you should be understanding it. Like what data can you get when they say 40% mass by mass? First we'll try to do that. We'll calculate the mole fraction of NaOH in 40% mass by mass aqueous solution. Now if you are thinking one component is NaOH, what is the other component? Now when they said it is aqueous solution, I clearly explained you in detail what are aqueous solutions. The solvent should be water. So my one component is NaOH here and my other component will be water. So I don't think there is any confusion regarding the components. So I need to calculate calculate the mole fraction of NaOH. I need to calculate mole fraction of NaOH. So first let me write the formula for that. What do I need to calculate the mole fraction of NaOH? Number of moles of NaOH divided by total number of moles of all the components present in the solution. So now it will be equal to number of moles of NaOH plus number of moles of H2O. Okay, number of moles of NaOH divided by number of moles of NaOH plus number of moles of H2O. Now, do we have the number of moles given? No. Do we have the mass directly given? No. But we have percentage mass by mass, okay, composition, okay, of the solution. So what he has told, 40% mass by mass, okay, 40% mass by mass of which aqueous solution? NaOH aqueous solution. So from this, what should I understand? Okay, I already explained you how to write this. 40 grams of NaOH, 40 grams of NaOH present in, as it is mass by mass, present in 100 grams of solution. 40 grams of NaOH present in 100 grams of solution. Now from this, what did I get? I got mass of the component NaOH, but I have mass of the solution, but I want mass of the component water. But can I get it? Yes, I can get it. So first let me write down. I got mass of component NaOH. I need mass of water. How do I get? By subtracting solution's mass minus NaOH mass. Yes. So can I see? Imagine. Okay. Now mass of solution is equal to mass of solution is equal to mass of NaOH. Mass of NaOH plus mass of water. Now to calculate number of moles of water here, I need mass of water. So let me calculate mass of water. Do I have mass of solution here? Yes, it is 100 grams. 100 grams is equal to mass of NaOH is 50 grams plus I want mass of water. So how much will I get? Mass of water is equal to 100 minus 40, that is equal to 60 grams. Okay, now I have mass of NaOH, I have mass of water. So let me calculate the number of moles of NaOH here. Number of moles of NaOH is equal to, what is the mass of NaOH given here? 40 divided by molar mass of NaOH is also 40. So 40 by 40 is equal to 1. In the similar way, let us calculate the number of moles of H2O, that is equal to 60 divided by 18. Okay, 60 divided by 18. Now you got the number of moles of NaOH. You have also got the number of moles of H2O. Now we have the formula with us. Mole fraction of NaOH is equal to number of moles of NaOH divided by number of moles of NaOH plus number of moles of H2O. Now when you have the number of moles of NaOH and number of moles of H2O, I know you people are very smart enough to do the calculation further. So further calculation, by substituting the number of moles, this calculation and the further calculation of calculating number of moles, you people will be doing by yourself. Okay? Clear? Because I have shown already for the previous question how do we calculate. Now I have shown how to calculate number of moles. Now please substitute and find out the mole fraction of NaOH. In this question, what is the major thing you have to focus about? How to crack information from this concentration term, 40% mass by mass. Okay, so you will do the further calculation. So now we are going to do our next concentration term, which is parts per million, okay, and parts per billion. With that, we will be ending our concentration terms. So let us do our next concentration terms. Okay, this calculation you will do by yourself. Okay, let's see the next concentration term. Let us see the next concentration terms. Last but not least, ppm and ppb. Okay, parts per million, parts per billion. How should I understand these two concentration terms? Mass of solute in grams present in 10 to the power of 6 grams of solution. So what is, okay, parts per million, mass of solute in grams present in how many grams of solution? 10 to the power of 6 grams of solution. Parts per billion, mass of solute in grams present in 10 to the power of 9 grams of solution. So how much mass of solute is present in 10 to the power of 6 grams of solution is ppm. Mass of solute present in 10 to the power of 9 grams of solution is your PPB. How can I write it in the form of a formula? ppm, parts per million, ppm is equal to mass of solute in grams divided by mass of solution in grams into 10 to the power of 6. Okay, in formula way, if you have to write it, ppm is equal to mass of solute in grams divided by mass of solution in grams into 10 to the power of 6. Okay, then what is your ppb? Mass of solute in grams divided by mass of solution in grams into 10 to the power of 9 into 10 to the power of 9. Okay, so these are the formulas you can use in the numericals when you have to calculate parts per million and parts per billion. Both the formulas are same, with the only difference, because it is per million it is 10 to the power of 6 here, because it is okay, per billion it is 10 to the power of 9 here. How to understand it? If someone says, okay, if someone says 20 ppm, okay, if someone says 20 ppm, how should I understand it? Okay, 20 grams of solute present in 10 to the power of 6 grams of solution. Okay, if I am saying 20 ppm, what does it mean? 20 grams of solute present in 10 to the power of 6 grams of solution. In the same way, if someone says 45 ppb, what does it mean? 45 grams of solute present in 45 grams of solute present in 10 to the power of 9 grams of solution. Okay, 45 ppb means what? 45 grams of solute present in 10 to the power of 9 grams of solution is your 45 ppb. So this is how you understand both your terms, parts per million and parts per billion. Now, okay, it more than direct questions on ppm and ppb. Usually you get questions in the exam regarding ppm and ppb by linking it with other concentration term. Okay, it is difficult to understand orally in words. So let us do a numerical to understand how is ppm and ppb applied in a question with the other concentration terms. So let's do a numerical on this concept. Let us solve a numerical on the basis of ppm. And we have one more concentration term here, which is mass percent. We need to calculate the mass percent of 10 ppm aqueous solution of calcium carbonate. Okay, so I need to calculate mass percent of calcium carbonate. Okay, aqueous solution of calcium carbonate. So, okay, what will be the formula of mass percent? Okay, mass of solute, we already have seen this formula. Mass of solute in grams divided by mass of solution in grams into 100. So what is mass percent formula? We already did this formula in the previous concentration terms. Mass of solute in grams divided by mass of solution in grams into 100. Now, do we have enough data? Okay, we have been given it is 10 ppm aqueous solution of calcium carbonate. So let us try to expand this and get some information. 10 ppm aqueous solution of calcium carbonate. Okay, 10 ppm aqueous solution of calcium carbonate. I told you how to expand this. 10 grams of calcium carbonate. 10 grams of calcium carbonate present in, as it is ppm, how will I write? Present in 10 to the power of 6 grams of solution. If it was ppb, I would have written 10 to the power of 9. As it is ppm, what am I writing? 10 grams of calcium carbonate present in 10 to the power of 6 grams of solution. Okay, now I got my mass of solute, which is 10 grams of calcium carbonate, and I also got mass of solution, which is 10 to the power of 6 grams of solution. So I can substitute the values now. Mass percent is equal to mass of solute is how much? 10 grams divided by mass of solution is 10 to the power of 6 grams of solution, okay, into 100. So if I write this 100 into 10,000, 10 to the power of 3 divided by 10 to the power of 6, which will be equal to 10 to the power of 3 minus 6, that is equal to 10 to the power of minus 3%. Okay, so what is the mass percent here? Mass percent is equal to 10 to the power of minus 3%. Okay, so this is how you use ppm as one of the concentration term and calculate some other concentration term. This is how in this chapter we keep linking each and every concentration term. So when we go to the next class, okay, when we go to the next class, we will be learning few formula. Now you will be wondering what more formula do we have. Okay, now we have seen the individual concentration term formulas. Now in the next class we will be seeing, okay, formulas linking concentration terms, like relation between molarity and molarity, we have a formula. Relation between percentage mass by mass and molarity, we have a formula. Relation between percentage mole fraction and molarity, we have a formula. So those will be the formula okay, linking the concentration terms. So in the exam, when they give you two concentration terms, always a long process, it is a very time consuming process in the exam. So when you have direct formulas, okay, linking concentration terms, it is very easy for you to use them in the exam and get to the answer very quickly. So in the next class, it would be the last class of the concentration terms. So we'll be seeing the relationship between concentration terms in the next class. With that, we'll be winding off the topic concentration terms, and then we'll be going to the next very important topic of this chapter, which is vapor pressure. Okay, till then, hope you loved the session today and understood all the concentration terms I taught you today, mole fraction, ppm and ppb. I will see you in the next session with a new concept of relationship between concentration terms. Clear? Till then, see you. Bye.